Thanks very much. And I would like to, it's really a privilege to be here. I'm Jonathan Rubin. I'm the director of the Margaret Chase Smith Policy Center at the University of Maine and the School of Economics. And I have my colleague, Adam Dagno, and I were tasked with what's climate change mean for Maine's economy. That is obviously fairly simple. And that's why you don't need those consultants that you just hired, because we've got this covered, right? Isn't that right, Adam? We're done. But it's a real privilege, and I'm really proud of all the state of Maine for taking this on. So a few things here. We expect climate change to impact the whole economy, but certain sectors more than others. Those are the energy, transportation, tourism, recreation, agriculture, forest products, and marine fisheries and aquaculture. Important to remember here when you're trying to think about the economics of this is that the benefits and the costs of the mitigation and actions we take, how it affects our economy depends a lot on how those actions are taken. We need smart, data-driven approaches that adapt as we learn more. So one of the recurring themes in my comments here, or our comments here, is the choices we make matter in how we approach this. It's not just an absolute. It matters how we go about this. This is the slide that I think Stacy Knapp alluded to earlier. The gray line on the top is the value of economic output in the state from 1997 through 2015 or 16, the last year that we had consistent data sets. And the blue line is the greenhouse gas emissions per dollar of state output. Greenhouse gas emissions per dollar of state output, and that's falling. And that's what we want. We want we want to maintain our economic strength and grow, but we want to have that wedge, that divergence between economic value and greenhouse gas emissions. So that's a good trend. That's what we want to see. But what we want to see is that gap between those two lines to get bigger and bigger, and that's what we need to do. Now, energy. On the consumption side, as mentioned a bit earlier, 2/3 of Mainers roughly use oil for their home heating. And petroleum products make about 50% of all energy used in the States. That's on the use side, the consumption side. On the generation side, in that pie chart, you see that all the green shades of green are wood, wind, and hydro, and the blue is natural gas mainly, and a little bit of petroleum. That is the net generation in electricity, and that is produced within the state. Or the biomass, the wood, the wind, and the hydro are within the state, and the petroleum, of course, is imported, and the gas is imported. So this means that we have some easily identifiable opportunities here. Fuel switching for, say, heat pumps for home heating, electric vehicles for transport, and, of course, renewable energy generation is also an opportunity here. Now, these are expenditures. This is not volumes. This is money. This is the amount of money in millions of US dollars by end-use sector: commercial, industrial, residential, transportation. So we see, and the colors represent petroleum, electricity, natural gas, wood, and biomass. So what stands out there is that big blue column on transportation. That's money, since we don't have natural gas or oil, in the state, that is all money that's leaving our economy and we're using when we use our transportation services. Now, let's look at transportation just a little bit more detail. It's about 50% plus, maybe 54%, I think I heard Stacy say earlier today. 94% of transportation energy is oil. The rest is, of course, ethanol, with about 1% or less than 1% being electricity. So that is where our transportation energy comes from. Per capita, we're about average in terms of greenhouse gas emissions in the transport sector per person. Now, so transportation is a major driver of greenhouse gas emissions, but and also true that the climate change does affect transportation infrastructure. In fact, higher temperatures can lower pavement life, freeze-thaw cycles can speed up bridge fatigue, extreme weather events can have culvert washouts, and of course, coastal road and coastal infrastructure can be all damaged. Now, opportunities, though. Now, here, this is. I want to think not negatively today. You know, we are all here because we're worried, but I think we also should think about opportunities here. As we think about the transportation sector of the future, we can have more active transportation, more walking, more biking. We can have better air quality, less congestion. We can have more opportunity, more mobility. I think one of the key aspects here that message I want to say is we think, as I was saying, we need to design policies in a smart way, and we have to bring along everybody with us. If we have more EVs, it has to be accessible to all, not location and by all socioeconomic groups. So we have to really think about solutions that benefit everybody, but I think there really are benefits here. No one likes standing in congestion. Everybody probably wants to walk more after New Year's Eve resolutions. And so there's some real opportunities, and we should embrace those rather than fear them. Tourism and recreation. Now, this is a really difficult one to think about from an economics perspective because what do we know? We know that the tourism in Maine is dominated by outdoor and recreational activities. What do we know? Winters are going to get shorter, the shoulder seasons are going to get longer, and the summer is likely to be expanding. So some parts of our tourism economy are going to be hurt and others are going to grow. And how this shakes out is complicated in part because it depends on what happens in our neighboring states. Do our ski resorts gain because people say, oh, Maine's got the last good snow? Or do people say, well, I'm not going to ski as much, right? So it depends not just on what happens here, but it depends what other state occurs in other states and how those citizens change their behavior. And so that's a real challenge to determine. We heard some stuff on the forest products industry, how important it is. I will simply say that from an economics perspective, I'm not going to repeat those. I'm not going to repeat some of the forestry stuff that was talked about earlier, but I will say that there are some opportunities in the forest sector. For instance, we can have mitigation through more wood products that store carbon. What am I talking about? I'm talking about things like cross-laminated timber that can substitute in construction for steel or concrete that both locks up carbon and produces less carbon. So there are opportunities here as well, not just challenges. Agriculture, again, I want to stress the opportunities here in agriculture, which is we can probably sequester more carbon in manure, better manure management, and via better soil health. We'll probably have more availability for crops. So ag, depending on how this works out, ag might do okay. Marine fisheries, we know it's a very large and important industry for the state of Maine, and we know that climate variability is likely to lower employment and economic value, and there's studies that have shown that. So that is pretty well, we can anticipate that with pretty well, with good confidence. Aquaculture, it's an opportunity, and new markets are an opportunity. I want to say a few critical issues here. The policies and the ways we choose to mitigate and adapt really matter. And this is a little technical and a little wonky, but if you set performance standards or you call certain technologies as winners, the way you set up these types of things matters, and it greatly impacts the costs. And there was a question raised earlier, I think it was to Stacy, saying, well, do you count upstream emissions for natural gas, the production of natural gas? And I believe she said, no, we count the emissions as burned in the state. It's important to treat, when you're doing studies and trying to understand economic impacts, you really have to look at all sectors of the economy, residential, transportation, commercial, equally. So if you if you do or do not count upstream natural gas emissions, you also have to ask yourself, do we count upstream fertilizer emissions? Do we count the fossil energy that is used to create standard non-organic fertilizers? It's really important to have consistent system boundaries when you estimate this stuff, or else you really can't compare fairly. And so I'm trying to suggest some ways to think about how we should think about these things. Also, where can Maine have the most impact? Fuel efficiency standards are set by the federal and California, although they're having a little disagreement right now. But the feds in California set our fuel efficiency standards, so we can't really affect those. We can choose which vehicles we choose to purchase, and we can give state incentives for electric vehicles, so some things we can affect, some things we can't affect. So again, we got to be smart about this. Where is the biggest bang for the buck? And finally, I'd like to mention what's happening to our workforce. It's about jobs, right? And our economy is changing. This next picture shows from 1990 to current changes by sector, the changes in job growth or loss by sector. And we can see growth in healthcare, administrative services, educational services, and we see a loss in manufacturing. Now, we need to design policies that bring along everyone and pay attention to the job impacts, not just the monetary impacts. And so we have to just be very smart about how we do this. Finally, a technical point, but I feel compelled to discuss it, which is these are recommendations for the Climate Council on discount rates. I know here's what this is, right? Damages occurred today, 20 years, 50 years, 100 years from now. We are spending money now to make changes. So we have costs and benefits and damages occurring at different time periods. How we treat those matters. For instance, your $1 million nest egg that you've got stashed away, 100 years from now, at a 7% rate of discount is worth about $1,000 today. $1 million at a 7% discount rate is worth about $1,000 today. At a 3% discount rate, it's $52,000, and at a 2% discount rate, it's $138,000. So the choice of that way you compare benefits and costs across time periods is really, really important, and it swamps most other decisions in benefit cost analyses. There's a consensus amongst the economists of the field, and I show the consensus numbers of a 2.5, 3, and 5% discount rate as recommended. And I'd be happy to talk with anybody about how these are done. But ultimately, these are social choices being made by our legislature and the Climate Council, and you need to think about how you want to address these, because it is a social choice. Finally, I just want to conclude saying climate change will affect all parts of the economy, but not equally. The good news is the historic data shows that we have a delinking of GDP, or gross domestic state economic output, and greenhouse gas emissions. That's great. And there are opportunities here, and we really have to think positively. We've got to go and bring along everybody with us by thinking about opportunities. And I'll stop with that. Thank you.